Hello friends, let us start with our new topic, inverse of a matrix. In this lecture we will be studying two topics, inverse matrices and Gauss-Jordan method. Now if the inverse of a matrix exists, the matrix is called as invertible and non-singular, and we can write a matrix in the form of A into A inverse will be I. A is an n cross n matrix, that is A is a square matrix. So if the inverse exists, it will be written as A into A inverse will give us I. I is our identity matrix. Now what happens if the matrix is a singular? Now if the matrix is singular, the determinant of that matrix is 0. You can find a 0 vector for Ax equals to 0. That is some combination of the columns will give us a 0 vector. Now consider this matrix 1, 2, 5, 10. Now if C is equals to minus 5 and D equals to 1, this will give us 0. But in the case of a non-singular case, this is not possible. For a non-singular case, C and D has to be 0 for a matrix which has to be non-singular or invertible. Let us see the non-singular case now. So this is the non-singular case, that is the invertible case. For this invertible case, the determinant will be non-zero and the columns will point at different directions. So for C and D has to be 0 to give us 0 vector. So if Ax equals to 0 for an invertible matrix, X has to be 0. No other combination can give us 0 other than the 0 vector itself. So for example, consider this matrix 1, 2, 4, 7. There is no combination of C and D that will give us 0 except for C equals to 0 and D equals to 0. So this is the invertible case. Now we will be finding the inverse using the Gauss-Jordan method. Now we are taking the example, the same example 1, 2, 4, 7, because we know here the determinant of this A is 7 minus 2 into 4, which is equals to minus 1. The determinant of A is not equals to 0, and the combination of this will only give 0 if the x vector is 0. So this A is non-singular and invertible. Now we will be finding the inverse of this matrix. Now we know that A into A inverse will give us I. Let us take A inverse as the matrix ABCD. Now we can write this as A into A inverse equals to I. Now we will split those two columns AC and BD and write it as AX equals to B1 and AX equals to B2. Here our B1 is the first column of identity and B2 is the second column of identity. Now in the elimination lecture, what we did was we augmented this A matrix with B1. Now in this lecture we will do the similar thing. We will augment A with B1 and B2 and we can write it in the form of as A and I. Now after all the operations, this will get transformed into I and A inverse. Now let us start our row operations. Now what we need to do is we need to make 1, 2, 4, 7, 2, 1, 0 and 0, 1. So similarly we will be doing the row operations. So first we need to get rid of this 4. So the row operation that we do is A2 equals to A2 minus 4A1. Hence this becomes 0. The same operation has to be done on the identity matrix and this 0 becomes 4. Now we have a minus 1 here, but we need a 1 here. So what we will be doing is doing the second operation. The second operation that we do is A2 equals to A2 cross minus 1. So this minus 1 will get replaced by 1 and the identity matrix will also be getting multiplied by -1. So this will become 4 and -1. Now the only remaining part is this 2. So we will be doing the upper elimination. In the upper elimination we will be just using this 1 to get rid of the 2. So we will be doing the operation a1 equals to a1 minus 2a2. So no operation, so as this is 0, nothing will change this 1 and this will remain the same 1, and this 2 will get changed to 0. The same operations has to be done on this, and our matrix becomes -7 to 4 and -1. So this was the augmented form. We wrote it in the augmented form as AI, and this is the final form. Now this is I and this is A inverse. So our A transform to I and I transform to A inverse. Now let us verify it by multiplying A and A inverse. Now let us verify it. We will be multiplying 1 to 4 7 and -7 to 4 and -1. So what we will get is -7 plus 8 by this row and this column. The second will be 1 cross 2 plus 2 cross -1 by using this row and this column. Third will be, the part here will be -28 plus 7 cross 4, which is 28, and this, and the last will be 8 minus 7. So this will give us 1, this portion will give us 0, this will give us 0, and this portion will give us 1. So this is the A inverse. In the next part we will be seeing the example of a 3 by 3 matrix. Thank you for watching.